Hello. Hello, everyone. Hopefully, you can hear me. And welcome. Welcome once more. I know. I know. It's been a little bit of a recess. I, I understand. Hopefully, we had time to calm down, to refresh our mind. At least I did. To flush the cache a little on some of the frustrations from before. And whew, breathe in and breathe out. Welcome, everyone. Welcome, Penguin Operator, Rudy Fans. Thank you. And yeah, I mean, guess it's time. It's time that we continue working because hopefully we're going to be able to finish anything that is not related to tests today. I'm going to close the test file because I don't want to see it. All right. So, welcome back, everyone. There is a little bit of an ongoing question that I have, which is what are the things we have left, right? So I assume that the best thing we can do is go to our list of to-dos and take a look at them. Um, we have a to-do here that says whenever adding bytes to a block, for the sake of alignment, we should expand the user section rather than the footer because it could improve the chance of finding blocks for future requests. In fact, this is something we've already done and that was tied to our previous design. The new design fixes this. Implement footer and header functions. We already have those, and in fact, they're right here. So bye-bye. And we have another to do in terms of style, and it's to change right block for leftover block whenever we have, the need to do so. So I think this is a valuable thing. Sometimes we use like right block here when we do partition of worth it, right? So I think it's just suggesting, oh, maybe like a better name is leftover block, right? Because it's like the block that was left after the partition. It's a very sort of, minimal suggestion and like to do, but it's still good to implement. It's a little bit relaxing too. And so we can just do that. Right? And so perfect. And I think there is a scenario where when we do leftover block, things start to change. So I think it's something like this, where we have, hello, a polyglot. Welcome to the chat. Is that an OS? No, this is not an operating system. We're just creating a memory allocator from scratch, which the memory allocator doesn't really have to be integrated with some operating system. It can be just a completely standalone program. A virtual memory pager would have to be coupled to an OS, but fortunately, this is a little bit different. This is a memory allocator. So, yeah, that's mainly it. It's cool. Yeah. It's like the thing that allows you to manage the program of, the memory of a program. So the programmer requests memory and frees memory, and we're the ones in charge of managing all of that, being the middleman in those types of transactions. So yeah, that's mainly it. Yes. It is exactly like malloc. In fact, like malloc is an abbreviation for memory allocator. So yeah, it is the exact same thing. We're doing just that. Um, and yeah. So here we're just fixing some little things that we want to. Percival Soxo. Yo, first time on a programming stream. Yo, let's go. We're doing a memory allocator. It's great that you're joining. Linux, well, currently not really. Like a memory allocator can work on any platform. Like because it's just going to be coupled with the language. Um, Currently, I'm working on Mac because I only have one laptop, and that Mac laptop happens to be a Mac, and so it's all I can use. Um, Linux is an OS, an operating system. So yeah, let's see. So the best one ever. Yo, only heard of Arch. Yeah. Yo, let's go. And yeah. Anyways, um, I think there is no problem if we declare the variables this way, right? Yeah, yeah. I suppose Linux is not per se an OS. Yeah, 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 yeah. That makes sense. Um, it's technically a kernel. Okay. Yo. I just like to interject for a moment. What you're referring to as Linux is in fact GNU Linux. Yeah, 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 yeah. GNU plus Linux. Linux is not an operating system unto itself, but rather another free component of a fully functioning GNU system, made useful by the GNU core libs, shell utilities, and vital system components comprising a full OS as defined by POSIX. Yeah, yeah, pretty good. That is exactly. Um, if yeah, sorry. Like I usually just say, an OS, but yeah. In fact, if I remember correctly, Linus Linus was attending the talk by one of the GNU contributors when he proposed, or like when he said, "Oh, can Linux just be integrated with GNU and just follow the POSIX system?" And anyways, irrelevant. But yeah, um, we have. Is it okay to say it's Linux? It's just a meme. Oh, I see, I see, I see. But yeah, but it's technically correct. And in fact, one of my favorite lines, I think, if I open Firefox here, um, I have bookmarked the Linux kernel coding style. And if I remember correctly, one of the first lines, it's like, yeah, this is a short document describing the preferred coding style for the Linux kernel. Coding style is very personal and I won't force my views on anybody, but this is what goes for anything that I have to be able to maintain. This is Linus, if I remember correctly, and I'd prefer it for most other things too. Please at least consider the points made here. First off, I'd suggest printing out a copy of the GNU coding standards and not read it, burn them. It's a great symbolic gesture. Anyway, here it goes. So and then he introduces the coding style for C when it comes to the kernel. So, so it's very, I don't know, it's kind of funny. Um yeah. All right, that being said, oh shit, wait. Why is it I see the kbps are going crazy. Okay, it's fine. Um yeah, so side effects. I use Windows XP, but I'm doing pretty good. OG. Spend most of the time on Windows 7. Yeah. Yeah, that is true. Anyways, so here we were taking a look at this. Andrew, maybe you know the answer to this, but here we have a variable, right? Here we have a variable that's declared as leftover block. And then later down the line, there's another variable declared with the exact same name. Is this a problem? And I ask this mainly because um, previously we had a problem with this, with like these two guys shared a name, and then the debugger would like be extremely confused and would happen all sorts of things. I would argue there is no problem since like, you enter this if and only then you declare and then you return, and you only get to this place if you haven't entered that if. So like they're never going to exist, they're never going to coexist. I just remember that the bugger was behaving all weirdly. This line about new coding style makes a lot of sense. Just try to read any new code base. Wait, I would have to read one new code base because I haven't really seen it. I don't know what is motivated. Maybe I'm missing some. Uh, maybe I'm missing some strange C knowledge, but I think it's okay. Yeah, I think it's okay too. Um, wiki.os detecting memory. what is the third paragraph? Let's see what the third paragraph says. This seems like a legit link. Let's take a look. You just standing, I'm still standing, better than I ever will. Looking like a true survivor. Okay, so let's see the wiki of OS Dev, and it's just making sure we're not a bot. So there's a comma afterwards you skipped. Oh, sorry, wait. So, oh, it's just because it didn't highlight it. I see. Comma, AX, underscore, underscore, equals 0xe881. There you go, okay. Read the third paragraph. This function doesn't work in real mode. Instead, it's supposed to be called from 32-bit predictive mode. It runs the same information as function this. Perfect. Should be available on everything made after 1994. Since this is meant to be used in protected mode, the int instruction cannot be used to call it. The correct calling procedure is unknown, but it might be the same as for protected mode as bias. Further information is probably buried in a compact technical reference manual somewhere. So, wait, it's kind of fun to collect all of these pieces of like documentation or media where they just have like the most random comments in the middle of the document. Yeah, further information is probably buried in a compact technical reference manual somewhere. Yeah, pretty good. But yeah. Oh, sorry, close Firefox. No. Okay. But yeah, I think it's very funny you reminded me of but yeah, I think we have the leftover block. I think the variables are fine. If anything, we can just change them later. But I think we're good to go. Okay. So this to do, bye-bye. Now we're gonna look for more to-dos that we have. Because we have many. Expand the heap. Do you want to expand it by the exact amount or do we use some heuristic? This already solved. We have considered the case where we run out of memory. Ooh, okay. So this is the case where we're not able, the heap runs out of memory. Not the heap, sorry. The system runs out of memory to give us. And so if I remember correctly, oh, sorry. So ran out of memory and then we return. So do we know, actually, what does sbreak return when there is no more memory? Ooh, returns the value -1, cast to a -1 pointer value. Okay, that's great. So here with memory sbreak, I think we made it so that the increment, it would just increment and do that. And then if anything, it just, yeah, I see. So what we're going to do is we're going to capture what the result is. Maybe just use a char star pointer, result. And then say, okay, if, how would we compare if these things are, because like if I just grab a void pointer, actually no, I mean, it's better to grab a void pointer. And then we say, well, this converted to a number, if it's equal to -1, right? Is this the correct way to know if there was an error? Because I imagine, right, like comparing just two void pointers, is that possible given that a void pointer doesn't really have, it's not a type that you should be using. Let's see. It's very funny you remember. By the way, I made an OS and made the same thing, but honestly, the malloc is much simpler. Actually, kmalloc, not malloc. Malloc is much longer. On Linux in practice, you will never encounter it because of overcommit, which is by default enabled. Is the argin mem sbrk a void star? No, it's like by how much we want to expand the heap by. So currently we have this as a stub. We just have this as a stub because what it's doing is it's just so we're working on this like like a Twig example, and then we're gonna wire the actual things. And by that I mean, notice that when we initialize memory, right, mem init here, we like call malloc, right, to like create a little sort of virtual space in which to play with our heap. So it's almost as if our computer had like, you know, however many bytes are specified of memory. We're gonna wire the actual sbreak and stuff because, you know, that's why we have these functions like mem sbreak and then etc. So let's see. If res or not, I think it should work if res is a void pointer, and if it doesn't work, just do this because we set res as a void star. There's no need for casting. I see. Hi, BizCreeper21. Welcome to the stream, and welcome everyone back. Yeah, I think I just do this, and then we should be able to just say, well, there is an error, right? So we need to return a null pointer. And sorry, we need to just return a null. That should be the null pointer. Perfect. So if malloc fails, we just return null, right? If we're not able to accommodate for more memory, if there's no way to expand this, then we just return null. And then we also need to take care of what happens on the second call to sbreak, which is over here. There you go. We need to return null. So we store res, void star res is equal to this, and then we return null, right? Perfect. With overcommit, OS always gives you memory even if it doesn't have it. But if you actually start to use memory more than available, it just kills a random. Oh, okay, that's interesting. Which may include your desktop environment. How funny! I was working on a really bad but break syscall a bit ago. LOL. Interesting. But yeah, we haven't wired the actual syscalls. We have just a little toy example so that we can actually run the not the pager, the allocator. Yeah, I think those are all of the instances of mem sbreak that we have. Yeah, there's only two, and we check what they are. So this to do is definitely done. Consider the case where we run out of memory. Bye bye. And now, we have another to perform the calculation of recyclable space before the expansion size. I think we do that already? Question mark? To perform the calculation of recyclable space before expansion size. Oh yeah, I remember what the problem is here. So yeah. So we need to calculate expansion size after we perform the calculation for recyclable space. And the reason is because if we first calculate the expansion size, so suppose I'm gonna transfer to the Excalibur for this. Let's see. Suppose that we have, say, a given block. So I need to zoom out a little and then make this a little thinner. There you go. So suppose we have a given block here, block of memory. And all of this is our heap, right? So maybe there's two blocks here. This one's allocated, but then this one's free, right? Now this one hosts 20 bytes. It's a free block of 20 bytes. And suppose the user asks for 22, right? The optimization that we're performing is we don't expand the heap by 22. We only expand it by 2, right? And then merge this guy with this guy. Perfect? So now the thing is, we calculate by how much we need to expand the heap. And the way we do it is we basically say, okay, right? Among all of these factors, which is the one that I should follow, right? So actually, now that I think about it, don't you know I'm still standing? Yeah. So what we need to do is we can create some sort of variable that's called something like what? Recyclable space, right? So I'm gonna transfer this color to here. Then we're gonna say, well, recyclable space, right? And the recyclable space is just going to be equal to not much, well, 0, right? And then here we determine what it actually equals to. Recyclable space is equal to this. And so what we do now is we say, well, expand the heap by either the expansion factor, right? The size minus the recyclable space, or this guy minus the recyclable space. So we either want to double the size of the heap, or like, expand it by however factor we've decided. Have the size and then subtract from it the space we can recycle, and then have the footer and everything minus the space we can recycle. And so, yeah, those are going to be the ones. And the expansion size is actually going to be, let me think. We're fine with this. Let's see. So, so null is 0. It returns 0, which by default means no error. Though Linux nor any OS care what you return. It's just $sign. So wait. So is an alloc supposed to return a null pointer if you just don't have enough space? So then you return null? I thought that was the spec. Let me know if that's not the case. Why did you add size of UN32? So this represents the header of the block, right? So wherever you see size of UN32, this represents the header of the block. And I feel we need to make this a little bit more evident, which was one of the like, what's the name? One of the goals that we had for today. And in fact, I think if you look at the stream title, it's like fixing alignment. And this is sort of what I mean by that. Sundo, out of your window looks like a Ceph. It's because it's a Ceph. So I'm currently on an internship and I am in San Francisco. So that's part of the reason why. You have a pretty good eye. Excellent. Yeah. So right now, I think that's sort of what we needed, right? Perform the calculation of the recyclable space before the expansion size. This is totally fine. And now we don't need to do this. There is no free block. Perfect. Are there any other to-dos? All right. Intro to do. So basically you're asking what context. Yeah, I forgot it was malloc, but I recommend return null pointer. Oh, yeah, so the thing here is like when I try to return null pointer, it's just like, oh yeah, this doesn't exist. So I'm not sure what it is. Like, is there a specific header that I have to include that has no pointer? And wait, where is null pointer defined? Yeah, I think so too, but in C. Yeah, C23, but I don't think I have C23. Yeah, it was officially introduced to the language in here. This pointer does not exist in all the versions of C. In these versions, you must use the traditional null macro or 0. Yeah, so yeah, they're the same either way, so I think it's fine if we just do that. So let's see. Okay. Um, okay. So perfect. 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 Everyone using malloc do if pointer equals null. Yeah. Yeah. So it's fine. Um, yeah. I imagine that like yeah, definitely I support C23. I just have to like look where to go and everything. And I feel like it wouldn't make much sense when we can just return null. Um, yeah. And I mean they are the exact same thing. So mm, oh yeah. So do we have any more to-dos as I was saying before? No more to-dos. So now let me take a look at some of these comments. All the masses reset into the tree. Yeah, so we want to start writing sort of the doxygen for some of these functions. Where we can say, right, let's just pass that. And then here we say, okay, brief, right? I have a brief allocate size bytes. Allocate size bytes. And then it returns pointer to memory section containing at least size modifiable bytes. Yeah, it would be a way to describe it out of many. Free, we can add here a description that's something like brief, sort of freeze a previously allocated memory block. Then we include a remark here. So, or well, I think a param for PTR that says pointer to block to be free must be a pointer returned by a previous port dynamic. Perfect. Awesome. And here we return nothing, so no need to do that. And finally, realloc, right? So realloc, a way to describe realloc would be it reallocates, or like, you know, yeah, I guess reallocates the information in memory block pointed to by PTR to a new memory block of size at least size, right? And then here we put a parameter size that says size of the new memory block to which transfer. Yeah, size of the new memory block. Then finally it returns pointer to the new memory block. Right? Perfect. Okay. Let me read the chat. Wait. This is my kmalloc, by the way. Memory to kmalloc. Move id, move xd, move all. Whoa. What is this? Wait, is there a what is kmalloc compared to malloc? So wait, what is kmalloc? It's a fundamental function in the Linux kernel used to allocate physical virtual memory and contiguous blocks. Let's see. Pop struct kmalloc. Okay, kmalloc is typically used for physically contiguous allocations up to page size, but also supports larger allocations up to kmalloc size, which is hardware specific. I see. Kmalloc is typically used for physically contiguous allocations up to page size. It also supports larger allocations of the volumes. So I imagine there is no, is there a K3? K3 Linux kernel? Oh, yes, there is. So how do they differ from each other? Is kmalloc just in like, some sort of protected memory region? Yeah, you can just, wait. Oop, well, it doesn't have new lines. That's weird. What do you mean? Oh, the Twitch chat? Yeah. Twitch chat runs over IRC, which doesn't support new lines in a message. Twitch chat runs on IRC? Yeah, you can use any IRC client to connect to Twitch chat. It's just an in-kernel malloc. Malloc is cooler. Okay, but like, what is the difference? Because like with malloc, right? Or like, I mean the difference in functionality, right? Like malloc tries to allocate out the blocks efficiently and like, keep track of your memory blocks. Does kmalloc do the same? Because if so, a polyglot, your implementation is like just a few lines of assembly, which leads me to think it's just some sort of linear allocator. Oh no, I was just interested to know what kmalloc was, since I didn't really know about it. Oh my god, why is the letter so small? Dude, okay. The kmalloc functions operation is very similar to that of user spaces within a malloc routine, with the exception of the addition of a flags parameter. The kmalloc function is a simple interface for containing kernel memory in bite-sized chunks. If you need whole pages, the previously discussed interfaces might be a better choice. For most kernel allocations, however, kmalloc is the preferred interface. The function returns a pointer to a region of memory that is at least size bytes in length. The region of memory allocated is physically contiguous. Oh, physically contiguous. Interesting. So physically, like RAM, physically contiguous. On error, it returns null. Kernel allocations always succeed unless there is an insufficient amount of memory available. Well, I assume so, right? Because if you're the kernel, you don't really have much access to a virtual memory pager. So it has to be a physical, right? Because then how does the virtual memory pager obtain the memory it needs to perform its task? So I assume that it is physical memory, like quite literally physical memory. I see. Interesting. Physical is the memory address in the CPU itself. Wait. I'm trying to go back. Kmalloc is the malloc of the kernel, basically, pretty sure. Yes, but like I'm saying, what's the difference? I don't know, in my OS I used kmalloc to allocate pages and malloc to allocate context-dependent and unexact amounts of memory size. It's what I did, but I don't really know about Linux. That's why. Physical is the memory address in the CPU itself. You have access to virtual memory, but also physical. The CPU can translate some tables to physical memory, and that is virtual memory. So you can protect physical. No, yes. Like virtual memory would be what your malloc does, right? Where it would be contiguous in virtual memory and stuff. But I imagine the difference between the two is that kmalloc, since it needs to be for the kernel, cannot make any sort of calls related to virtual memory paging. It just needs to do it like in literal physical memory. Is that the right notion of why they're different? Or like what makes them fundamentally different, or what makes kmalloc be needed? It can map virtual memory. Can you expand on that? I'm not sure if I'm understanding exactly. Um, mm, okay. The kernel nearly always also has virtual memory. Okay. But then, what is the difference between the two? Or like, why do we have a need to have kmalloc? Could you just use malloc? Maybe kmalloc gives you a few more goodies and stuff, but could you technically just use kmalloc? Could you technically just use malloc? And let me guys know. And I imagine like maybe the advantage is just the flags, as I was saying before, but you know, It's like a little. I think if we just look up difference between malloc and kmalloc, and hopefully the difference is not, oh, one is used in the kernel and one is used in the user space, and something more substantial. Let's see. I'm pretty sure the malloc you can call in kernel code is not the malloc you call in user code. Linked into the kernel. They share the same name, obviously, but that's about it. Answer to the second one. Assuming that you're using Linux OS. Regarding to the first one, please have a look at my comments. So, difference between functions, they differ only in that the malloc can be called in user space and kernel space, and it allocates a physical fragmented memory area. But kmalloc can be called only in kernel space, and it allocates physically contiguous memory chunk, or something else, right? Kmalloc uses point. Okay. So it says Twalberg, no, Jekin responded, what operating system are you using? I'm interested to know where did you read about malloc in kernel space, assuming that you're using Linux. As I never read about a malloc implementation in the kernel space in which I can use kmalloc malloc depending on the requirements for the driver. Moreover, malloc in the user space is not even a primitive because calls dlmalloc, which calls mmap or break, yeah. After you post, I tried to grep in the overall kernel and I could find malloc implementations only in user level O2 utils and user level drivers. Let's see. In a nutshell, there is wait. MyOS, which is very different. Malloc uses kmalloc. In a nutshell, there is a physical memory manager. Yes, a virtual memory manager. Yes, and kmalloc kind of just allocs physical mem and maps it to kernel space, while also allowing non-page bound sizes. Okay, it allocates physical memory and maps it to kernel space, allowing, sure. So to explain, at least from what I've done read from other projects, or at least it depends on the OS, the rabbit hole of OSs. Yeah. I mean, I guess so. Yes. You know, maybe I'm not as experienced to understand fully. But yeah, over here we added the doxygen to for everything. And it seems like our code is basically almost complete. Which is absolutely great. You know, love this. I think actually the doxygen goes in the header files, right? Doxygen usually goes in the header files, if I remember correctly. So I'm going to take this here. So nalloc. Let's find nalloc. Oh, sorry, I defined it in memlib, right? No, wait, where did I define nalloc? Hello? Nalloc? Yeah, there you go. Okay. So that's going to be nalloc, and then we're going to put this over here, the doxygen. Well, no need to separate. Well, a minute. I think we can just delete this code because this is old. We can shrink this a little bit. There you go. That's there. Then we transfer to free. We copy the doxygen. We go over here. And then we copy the doxygen again. Perfect. Then realloc. Don't you know I'm still standing? Okay, perfect. Yay. And so now we can live our happy lives. Ooh, error while processing. What happened? Hello? Where is this guy? Oh yeah, we don't care about this. Perfect. So we should be fine now. Yeah. Okay, perfect. So what we have here is this. So probably like you said, physical is RAM. Yeah, the RAM will hear and know, the bars do understand. Any address now. In 1989, they said, wait, how do we protect memory? And they developed paging. Paging is a way to protect physical memory and it translates memory. Yes, for sure. Paging, normal. Or any by itself, paging can only work. Yes. So I can't use. So if you access your virtual memory, you actually, yes. And if you access anything in between, you access the same offset. Yes, this is just the virtual memory, you know, like this is virtual memory paging. It doesn't, it is not clear how this relates to the use of kmalloc, because like, you have your virtual memory pager, which would be in charge of associating the physical pages with virtual memory pages, and so on and so forth. But kmalloc, I agree. But like, what are we? So is kmalloc just another name for Mr. Virtual Memory Pager? Give me a page. Um, if so, then I fully understand. But it's a little bit confusing on what it would be. Because if, according to what you're saying, if because this is just the concept of virtual memory and stuff, kmalloc would be just like, oh, please give me a page, and then you do whatever you want with the page. So then you can use malloc on top of kmalloc, because kmalloc gives you a page, and malloc manages whatever that needs, or maybe not a page, but like, well, it has to be a page because you can have at least pages. Either way, so yeah, that's sort of what I'm asking, right? Because then I see, not if kmalloc is not the virtual memory pages, I'm I would be kind of confused on why it exists. My understanding is on Linux, kmalloc is used by the kernel to allocate the physical memory itself, and malloc can allocate physical memory, but in the context user application itself. So kmalloc doesn't care who allocated it, but malloc does. Kmalloc is used by the kernel to allocate the physical memory itself, and malloc can allocate physical memory, but in the context of the user, yeah, sure. Yeah, but in that case, so is that the only difference? They basically do the same. They just, they function the exact same way. It's just that one cares about who the user, like, the user, and the other one doesn't. Yes, so that's what confuses. So what you're saying, if that's the only distinction, does that mean I can just replace every call to malloc in my program to kmalloc? I don't think that that's the case, right? TLDR, kmalloc doesn't care who called it, malloc does care. Take into account, I'm probably wrong, I don't know about Linux, but it's a pretty uneducated guess. I see. Don't worry. Like, that's why we're trying to figure it out, right? That's why I'm asking, because best Cooper 21 is no. Okay, wait. Okay. We have to solve this debate, because then I don't understand what kmalloc does. So you're saying no, right? So the only difference is not just the distinction between is the user using it or is the kernel using it. That kmalloc does something more. What is it? Is kmalloc just another name for virtual memory pager, and like you just ask to it to give you a page? In a nutshell, kmalloc is just malloc, but in the kernel. Yeah. But like, so is the like, could I replace every call to malloc in my program with kmalloc? Right? If you're saying the only distinction is kmalloc doesn't care, oh, I see. See what is being said. Malloc can be called in user space as well as in kernel space. It allocates physically fragmented memory area. It does not actually allocate physical memory. Physical memory can be mapped later. Kmalloc can be called only in kernel space. It allocates physical contiguous memory chunk. Memory allocated by kmalloc is reserved and locked, which cannot be swapped. Okay, this seems like a bit of a better explanation. Let me read that again. Malloc can be called in user space as well as in kernel space. It allocates physically fragmented memory area. Okay, physically fragmented memory area. So I imagine, you despite maybe you have like a 1 megabyte block, right? in virtual address that looks contiguous, but it's physically fragmented because, of course, you're going to be swapping pages all around your thing. So maybe physically they're just, out. Um, it does not actually allocate physical memory. Physical memory can be mapped later, yes. Kmalloc can be called only on kernel space. It allocates physically contiguous memory chunk. So this is what I was mentioning before, right? That like the difference is Kmalloc actually goes to the RAM, like actual physical memory. And it allocates that, right? And then that thing, like actual physical RAM, is then mapped to your, the kernel space, kernel address space, which is fine. When the kernel needs some memory for its own data structures, it uses kmalloc, I guess. I suppose. Kaido Titan, C++? No, this is C. The source is this guy. Okay, I see. Yes, you're right. Okay, I see. Okay. So, okay, sure, perfect. We solved the mystery, I suppose, on what kmalloc does, and great. Okay, so I think we're going to go here and take this oxygen out. And I think we need to merge these two. So this should go somewhere around here. There you go. Perfect. So we have our oxygen, very pretty, very beautiful, very everything. Yeah, so see, we have some comments that are left over. We don't want these. We already know this happens. This oxygen belongs here since this is not a global function. Parts of the program depend on this thing overriding. Yeah, that's really good. Call as blocks. Init, then nalloc. Yes, this is fine. There is no free block. Yes. Shrinking, expanding. Perfect. I think we're set. We're ready to go. So one thing that I'm curious about is what branch are we in right now? Please tell me we're not in the tests branch. Oh no. Okay. So I think I'm gonna just commit this and say tests and then test failed attempt at testing at creating a testing framework for our allocator. Perfect. And then we simply push this. I think we need to set the upstream too. And then we have origin here. And the name of the branch, I think it's exactly the same. Yeah. Test slash introduce unit tests. And we're good to go. All right. So I honestly want to check out the main. Well, before that, can we log? Okay, so I'm just gonna copy this. I'm just gonna check out main. Then in main, we just want to copy the exact same changes. And then I want to check out back into that thing to get whatever was in the header file. So git check out this guy. Oh, okay. Git stash. I want to git stash that, and then let's go to checkout that, and then I want to go to the header file and copy the header file. And then we check out main again. And then we do the header file. Perfect. Okay, awesome. Now I'm gonna delete this comment and so on. I'm just gonna get that dot git commit dash m, something like, I would call this a refactor, which would be something like, solve to-dos in mm.c and include doxygen for main functions. Perfect. Reset this, and then we push. Great. Okay. Okay, that's fine now. Let's take a look at the chat. So, not sure about the reliability of the document. Oh no. Okay, it's the best chance. Yeah, the comments on my code are funny. I want to see it. If you don't mind, of course. Like what? Let's see. Ah, my eyes, dude. Oh my god. What are we about to witness? Let's see. This comments down here explains the structure addresses so you can read this clearer, so you can find the structure of the code and the structure of the RAM and C, C++ terms. So got tired of looking for everything. I'll look for Notepad++ hyperlinks, I guess. Code structure. Ooh, these are semicolons. Is this assembly? No. Oh, what the hell? Brother, what are you? What? I'm telling you, this took me 6 hours to make the whole ASCII table. By the way, I didn't include non-printable characters. If you try to print them, nothing prints. I got well down tired of scrolling 500 lines to get to this down here, so well. Just so y'all know, I used to calculate the amount of sectors, so that's why the comments are here. 5 sectors already, probably more, just 14 more icons. Then I have finished the task manager, not with the UI, and now decided to make the icons, and I reached 10 kilobytes in 2,000 lines. I decided 10 kilobytes is too much, so I just made the code smaller than it is now. Yo, wait, that's a lot of difference. I jump back up to... Brother. What is... This is crazy. Damn. Coding everything in assembly. Absolutely insane. Wow. Yeah, 2,000 lines of assembly is like absolutely insane. Absolutely insane. Like, what the hell? Anyways, that's pretty good. Check the large amount of comments. Yeah, no, like, I was seeing the amount of semicolons that you have. Like, here, beginning code begins, right? It's like, oh, wait, where is it? Ah. It's not printing fully, just half. By the way, this is a copy from another OS I made. That's real mode, so I couldn't copy paste it. I wanted to copy and paste my own code, but they were made for different devices. Like there's so many random things. Here, when mouse position, I decided to put it on the stack. I regret that decision. Please don't zoom me. Pretty cool. Now an application that knows nothing yet. Time to I don't know. I'll make the desktop. Why not Dolo? This is me 5 days later. I regret it. The mouse worked. I didn't back up, and it doesn't work anymore. The mouse had scroll lock. Yeah, scroll lock. I didn't know that existed. It has been 1 month. I unregretted. I might have finished now. Only one thing left. The floppy disk controller, which is what I need, has vanished. It has been 2 months, and I still haven't made a disk controller. Although I could because I finished multitasking. Yeah, this is so funny. Yeah, pretty good. You're welcome, future me, and whoever will read this. Well, there you go. Your message reached us in the future. It's perfect. All right. 9 months ago. Damn. Your future self is reading in 9 months in the future. Excellent. Okay. But yeah, continue here with our memory allocator. I think so one of the last issues that we have left is everything related to alignment. So you'll see that usually we have a bunch of size of UN32T sprinkled around the code base. And that's because we know that represents the header size. But it would be better if we found a different way to represent this so that it's clearer, because it's currently very confusing. So, oh, shoot, what? Oh, I forgot to do git stash apply. git add dot, and then I do commit dash amend. Can I do this? And then include the message of the same message that we did before. Something like refactor, then solve all to-dos in mm.c, and what? Solve of to-dos in mm.c and what? And oh yeah, include oxygen for main functions. I think that does it, right? Too fast changed. Yeah, everything's fine. We get push. Yeah, I don't care. Git push, and then we're gonna force with please. Great. I'm the only guy in that repo, so we're fine. Great. Okay. So let's see. Check the comments. The blobs. Fun fact: the code is horrible. Also, I did actually use it because I quit the project for 2 months, and I did thank them. Size of UN32 is always 4. Yeah. I'm aware. It's just that like we want to make sure. But we don't want to put 4 as like a magic number. Neither do we want to use size 4 as a magic, quantity. I think we want to do something that's clearer. I'll take a look at what you say. So devs, whenever they release, add more bugs to fix later. Pretty cool. Pretty much. All right. Fun fact, that's one of these projects where you're like, what the hell did I do here? Okay. Yeah, as a fact, that was my first version. Why not hashtag define? Yeah, exactly. Like that's what I'm, no, that's what I'm thinking of saying like, hashtag define and then header size. The thing is that we have 2 different things related to a header, right? So we have the header of the block when it is freed, and then we have the header of the block when it's allocated. And so, yeah. So with that being said, we need to find a good way to name this, to name things, because, C implementations, yeah, I guess of course, like the C standard only never specify how many bits go inside a char, so or a car, however you want to call it. It's yeah. So what Rutifant is saying is completely right. Yeah, and size of unit would be 1. Yeah. So yeah, in bytes, but the C standard actually doesn't define what a byte is. They just say it's whatever the size of char is, if I remember correctly. So, so like technically, you could have a situation where the number that's returned is just 1. So yeah. Anyways, so we go back to this issue of when we're talking about header, we are talking about 2 things. So header we've been usually using to refer to the header of a block when that block is free. And by that I mean, remember that this is what a blocks in memory look like, right? They store size, left, right, parent, and then the size again. This is the header when the block is free. But once the block is allocated, we don't really care about the left child, the right child, or the parent, because this block is no longer in the red black tree. And thus we allow the user to start writing from here. So the user can override this information. And so now, in this scenario, the header of the block is technically just this guy. So there's like 2 notions of header. Header when the block is free, which contains the full range of variables, and header when the block is allocated, right? Which is something different. So how would we name them is sort of my question. I want to make it here, like clear on what it is, right? because we could call it free header, allocated header. I think that is pretty clear to me. I don't know if any of you guys would oppose to calling it that. Um, but yeah, let's see. Yeah, C defines byte as char, but char does not need to be 8-bit. Yeah, exactly. So there is char bit marker to find out. Yeah. So I've never coded in x86. Do you have fragmentation? You mean fragmentation? What do you mean by do you have fragmentation? In our memory allocator? Yeah. Because usually memory allocators that allow the use of free have fragmentation, like external fragmentation. Um, but yeah. So over here we have a little bit of Oh, I ran out of water. Give me 1 second. I'm gonna refill this. We're back. Hello. Let me take a look at this. Okay. Day fermentation. Okay, perfect. So we are going to continue here with this. So does anybody have an opinion on what the name should be? Because um, currently block header, it's like what we are using. I think if we just declare this as free block header, then it's going to be simpler to think of. Yeah, and then we can type def the struct. We can just create a different struct that simply thinks of this as the size field, and we can call it, allocated block header, right? So that's going to make a difference. I feel allocated is like a very long word, so if we just call it alloc block header, it's going to be better. Alloc block header is going to be better. Okay. So, Roboboboto. Hello. Welcome. But yeah, welcome. We were coding a memory allocator, and yeah, we're sort of fixing a little bit of the styling of our code and changing some names and stuff. So it's a very relaxing session, I would say, especially after the amount of hell that we had to go through with the tests. So I feel if we change the naming of this to free block header, it's going to be way better. Block header is now a function that should be regarded as bk free header, right? Think of it as that. And then over here, so we continue replacing any sort of mention to it. Now, no, new allocator? Mimalok is doomed. Yo, let's go. No. I mean, we're doing this for the sake of learning, so I'm not sure if we'll be able to overthrow Mimalok. Yeah, it would be a little bit of a difficult task, to say the least. Um, Yeah, let me accommodate the camera where it usually is. There you go. Okay, so we are renaming some of our variables so that they are a little bit clearer. The total space should be equal to, block free block header plus block footer. Perfect. And then we also need to change mentions of block header here. So it goes to the size. It's going to be free block header. Free block header. Perfect. And this one's going to be where? Free block header. There you go. All right, perfect, perfect, perfect. No AI. In my times, it was called no Photoshop or no copy paste. Yeah, unfortunately, the times have changed, unfortunately. And anyways, Penguin is, if anything, one of the most, friendly chatters we have around here. Always say hello. But yeah, so something to pay attention to is, once again, we have all of these guys like scattered around the house. And I think, so I don't want to start calling size of alloc block header all the time. It seems like a little bit ugly, but like, I guess it's the correct thing to do, right? Alloc block header, and then this block header. Yeah, I guess that's fine, right? I guess that's fine. Block set the size of an allocated block header. Perfect. So now we gotta replace all the uint 32s with with this, right? Sounds about right. So let's find the first occurrence and let's start pruning from there. For the next block, I think we just have to skip allocated block header. The reason why I'm not doing a replace all is because I want to make sure that like each of them is actually referring to the allocated block header and not something else. So let's see here. We're referring to the previous block, so it's definitely the allocated block header. Over here, we're trying to align, and so this has to be, okay, yeah. This has to be the allocated block header, then the allocated block header again. Perfect. The total space is the allocated block header plus the size of that allocated block, and then same here. If you're coming, never again, but they're never about to meet a friend, and they're never gonna never again. Okay. BK set size. So to set the size, we need to account for the allocated block header. To calculate block space, we need to, yes. To align, we also need that. Perfect. And then to calculate the total left space, we also need that. Perfect. Penguin is everywhere. Yeah, yeah. Penguin is absolutely everywhere. Yeah. Allocate block header. Great. So now we do size of uint 32t. Perfect. So the new size is going to be this, and then this is the allocated block header. This one also refers to an allocated block header. This one, yes, it also refers to an allocated block header. Size of allocated block header. Oh, what country are you from, if you don't mind me asking? Your name is confusing to me. Yeah. So my name is Arab, but I am from Colombia. And actually, I have no Arab ascendants. It's just that my father really liked the name. So I get why it's confusing. And I'm from Colombia in South America. So my first language is Spanish. My second language is English. Yeah. Alloc block header for recyclable space. And then we have another instance of allocated block header. Okay. Then we convert the expanded area, so yeah, allocated block header. And I think it's way easier to understand why the UN32 is there, right? So allocated block header. Because the reason is like, here it's easier to see, right? It's like go to the beginning of the heap, offset by however, the pointer that this block represents, and then skip the header. And that's what you give to the user. So now it's way clearer rather than a random uint32. Hopefully that will allow us to improve the, whoa, 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 whoa. Oh, I copied the link that you gave me. So, all right, let's paste it here. Block header, perfect. Then previous block minus previous size, it's going to be this. Yes, because we skipped the header. It seems like every single size of uint32 is actually just referring to the block header. Does this one refer to it? Block. So then we grade the pointer. Yes, it refers to it. The space needed. Yes, it refers to it. So size of allocated block header. Perfect. And then, yes, okay, size of here, okay. Block size, and yeah. So this is allocated block header, and then here the size of, we return this, and yes, we need to skip the allocated block header, and then allocated block header. Guys, I think we could have just replaced every single instance of size of with this. Unfortunate, yeah. Anyways, it's fine. Well, not even 32, I mean size of. Even 32. So we have 4 left. And this is the same as, yes, we skipped the allocated block header twice. And then here the same, and then these remaining ones, allocated block header. So officially, all of them were referring to the size of the allocated block header. Crazy. Anyways, let's see. So what do we have? Ooh, Tim XN, welcome to the chat for the first time. Do you think learning coding has become harder for new people getting into it now that AI is here? From my experience, a lot of people that I understand, that I started uni with have done things with code, but they don't care any bit about understanding it because Magic Button will give them everything they want instantly. I'm being honest, I also notice I have to hold myself back more and more. And hello, by the way. So, hi, Tim MXN. And yeah, I think, like, learning coding is, when it comes to holding yourself back, is definitely a little bit more difficult, right? Because you have the temptation of just saying, like, dude, why would I be stuck on a problem when I can simply just ask the chatbot, right? There is this sort of similar thing that I've noticed too. I'm also in college, and so many of my classmates have like these very impressive projects in the resume, but then you realize, oh, this was all vibe coding, right? And maybe you ask the person something about the project, and they're very sloppy when it comes to answering. Definitely the times are changing, right? People usually are starting to care a little bit less about the code and about the project itself, just because the thinking is being outsourced to AI. I don't think AI is completely evil though. I think there's people that are very smart with the way they use it, as long as you don't outsource the thinking. And the problem is finding where that line exists, right? What does it mean, or at what point when interacting with an AI am I outsourcing my thinking? Is very difficult, right? Especially because you feel tempted. So many people use this as an excuse, right? Like, oh no, but like, I chat with the AI to learn a little bit more. And that would be perfect if you were able to be completely conscious on how to measure yourself. But I think that's something nobody can do. Like, and thus I feel it's, it's better sometimes if you step out of the AI stuff and everything and just go back to how it was before AI and simply throw yourself into the void, try to figure things out, try to, interact, ask others about it, etc. And go through the struggle as a means to learn, because there's nothing better than that, in my opinion. So yeah, I feel it's definitely true. You can always learn programming the old way. Yeah, yeah. Rudy Fant is saying exactly that. Penguin Operator is saying, oh, sorry, no. Robobobodo is saying, oh, I didn't know you're a lady. My apologies. And it's replying to some comment, which I don't know which comment it is. Sorry, but no, she, her, by the way. Oh, I see. It's that comment. Right, yeah. Let's see. Ooh. Okay, of course, but I just mean in a more broad way. For example, when I was working in group projects, I basically got robbed of going at problems together with other people because they just used AI and did not understand what they were doing. It is a problem. It is a problem, but a positive way to view it is, it's not a positive thing, right? Because unfortunately, a big part of the new generation is basically coming out with not many critical thinking skills, right? In a more broad area. That is not to say that anyone from the new generation is going to be dull, like they have no critical thinking. No, that's not true, right? There's still people that have a very good critical thinking in etc. But, the overall percentage and the amount of people is like being reduced as we speak. It is going to become a problem. I'm completely certain that it's just going to happen. And in the future, we're going to have some sort of crisis that says, what are these software engineers? Not only software engineers, but like other professions too. We'll see this in like very far into the future, like far as in like maybe 15 years, 20 years, when the people that are currently in, say, I don't know, fifth grade, and that slowly but surely the majority grew up with ChatGPT doing their homework and stuff like that, start becoming and coming out into the world. It is a sad thing, unfortunately, and the way you can combat that is precisely by as Rudifat said, going back to the old way and making sure that your learning process is there. You're gonna have to deal perhaps with people that are not having the same mindset, but that is perhaps the importance of the mental strength that you need to have. Yeah, it is. That would be my comment on it. Oh, Colombia is cool. I'm actually learning Spanish right now. Yo, let's go, Robobobodo. Doing dreaming Spanish and hope to move to South America at some point. Yo, wait, that's perfect. Let's go. Yeah. Well, that sucks. Oh, once a name. Once a name. Welcome to the chat. Oh, that sucks. Try getting in open source. Have a GitHub. Always helpful for our CD. Yeah, makes sense. Writing is an important part of thinking, especially when learning. If AI is being used to generate anything, at least some thinking is being outsourced to it. Yeah, there is that sense too. And that's sort of what I'm defining as like, where do you really draw the line of what it means to outsource your thinking? And so the better way is to just completely get rid of the problem and then just do things yourself. Definitely agree, right? Part of the thinking comes into the writing itself. There are some ways in which we've seen it reflected when we've been working on a memory allocator, where we've been saying like, well, right, what should be the name of this variable? Very basic questions, but that have a little bit of thought behind them, no? Because if I name this the wrong way, it may convey the wrong meaning, and then somebody reading the code may be confused. And then slowly but surely, we start building this sort of interface. An example of that is the block functions, right? There were many proposals, or like at least thoughts that we were considering at the beginning on, okay, how should we access the metadata of a block? And we were defining, okay, maybe we should do it through a struct, maybe we should do it this way. And I proposed like, no, let's do this with these blocks, with these block functions, maybe it's better. And slowly but surely, we started, conveying into some sort of interface that seemed to make things very easy to do, right? So if you take a look at the code, there are some parts where it like, it reads almost like text. And that is what we want. We want the code to be very understandable. And you may say, well, in the era of AI, understandable code is not really a necessity, right? Because AI is able to read everything. The problem is, as you compound sort of layers after layers after layers, the margin of error becomes exponential, right? There's nothing more beautiful than a good interface, right? One that you understand immediately and one that seems to connect naturally with components. And in fact, I mean, it's been shown that the AI works better with well-written code. Um, if you are to say that, we should approach things as what is better to use with AI, so even in that sense, it wins. But I feel the thing that we can take away is not like, oh, the fact that you're writing clean code is not going to be useful because the AI is going to be able to read it anyways, is the thought process that goes behind that, right? You understanding the mind of somebody else that's trying to read things, you trying to say, in the future, I'm going to want this interface to look like this because of something I have planned. So there is a lot of ability that goes into that writing that I think is also necessary. Um, Exodry Pat. What are these emojis? I don't know. What? It's like they're petting like a little hat's face. Okay. So Elemental Magic's card game. Hello, I am Master Programmer in Elemental, and I defeated AI hypers. Great. Excellent. Sharif wants to take an AI, by the way. I feel this sort of answers most of it. So I do have to admit, um, if you gave me, and this is perhaps a little bit of a controversial take, right? If you gave me the power with a button to say, would you get rid of AI, at least in the coding space, I would ideally say yes, right? If we lived in an ideal world, I would say yes, because and it's a bit selfish, right? And I mean that because I really like the feeling of writing code and of thinking about these things and of being stressed about the tests because we didn't know, right, what is the right interface, what is the right thing to test. Um, I feel there is a value to that. And with AI, and I've mentioned this before, right? I am currently in an internship and they make me use Claude Code all the time. I've not written a single line of code. Everything has been prompted in Claude Code. And it reaches this point where things start sort of not making much sense. Not in the sense that, oh, I don't understand what's going on, but in the sense of like, it feels like the project has no more purpose, right? It feels like the project is not your own. Believe it or not, that is something that is relevant, right? It's something that's important. Having some sort of, belonging to the thing you're creating because it makes you care about it. So that would be one thing. Another thing would be the fact that, as I mentioned, and as Rudifeg mentioned, and if I remember correctly, it was also what was the name? I want to refer to you guys by your names. Let me try and find it. Oh, I think he lost the message. But yeah, somebody else in the chat also mentioned. Oh yeah, there you go. Vieto Vanquish, right? Vieto Vanquish. There is a good amount to be learned when writing itself. And also the fact that you cannot really draw a clear line of what it means to outsource your thinking. Most of the software engineer career, at least how I see it to be in the future, is not going to be about writing the code, unfortunately. That's a little bit of an unfortunate part. The good part is that it is going to still require that sort of component of decision making. And it's in fact going to be the core thing about software engineering. So the fact that the decisions and the importance behind them still remains is something that gives me the hope to continue. No, or like AI is going to take your job. Well, not really, right? Like the decision making is the important part of software engineering. It's just that now it has been heightened. Right? The thing is, how do you learn the decision making? Right? You only really learn the value of things when you struggle for days and later realize why they are the way they are, right? Like with the tests that we were looking at before and that everything was failing, that struggle, despite being extremely frustrating, is very helpful. Because how else do you learn? to create usually like actually helpful tests, if not by struggling. So there is a value in the struggle, and AI removes that from you. And that is the part I don't like about AI. But if you're very smart about it, which is a big caveat, because it's really difficult to be smart about AI, to use it correctly. But if you use it correctly, if you limit yourself and you're like, okay, I'm going to learn actually what's going on, maybe I'm going to use AI to perform like the really boring tasks, things that I know how to do, but that would take ages to perform. An example, migration of a code base, right? Maybe you need to migrate code, you know exactly, you wrote this code base, you just need to port it to somewhere else, to another language you already have domain of, right? It could be an example, right? Who knows? Um, but yeah, and and let's see. So, I want to keep reading the chat too. Uh, yeah, I think of most of what you said it similarly. I'll probably just have to look for more people that actually care about the critical parts, and open source seems like a good place to start. Yeah, open source also gets flooded with things a lot more and more. That is true. Yeah, but some projects still don't allow it in any capacity, right? Yeah, true. The problem is like you still can flood an open source code base with a bunch of PRs. They realize it's AI and then they just completely discard it, but you could still flood it. So, yeah. Is that VS Code? Yes, this is VS Code indeed. Meanwhile, me, that doesn't need AI to make hard to understand code. Interesting. Okay, yes, VS Code. Yeah, but they are rare. AI cannot create correct implementations, but the argument for AI code is even more absurd if your programming centers on specifications. In this case, AI involvement is a total non-starter. Yeah. Brother has added custom icons. Yeah. Kudumbara Pingu. Welcome, Kudumbara. AI will bring about world peace by bankrupting the US. Okay. It shouldn't really matter. I wouldn't worry about it. I see. Um, Christopher, welcome. Welcome to the chat for your first time. Wenzel, I didn't know it could be used with Excalibur. I thought it was an Obsidian thing. There's a plugin for everything, I guess. Yeah, you have an Excalibur plugin, so I like to use it. The US can't go background. Icon high. Da, 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 da. Interesting. Basically pro AI, but with provider spec nuances. Oh, it very much can. You got an internship, bro? Yeah. Wait, so you mean that about my view? I'm not that like as I said, like if it was in the power of my hands, I would get rid of AI. There is a sense in which you can say, like, there is no way to stop it. Like it would be really difficult to say, guys, actually, can we just stop developing AI? Like, but it's it's like at most, you know. But yeah. Um yeah, I have an internship and it's what I'm working on. So yeah, I can't accept that to itself. Reminds me of some people's making OSs fully vibe coded. Let's just say that's yeah, it's a little bit in a hilarious way. How's Columbia software industry? Are there jobs available? Meetups? So Columbia software industry is maybe not as advanced. Um, yeah, there are some meetups, there are some people. It's not completely precarious, but it's very different from the US, or at least when it comes to the side of opportunities. And yeah, it is perhaps the reason why I want to stay in the US. Not only that, but I'm also in like extreme debt because of college, and a salary in Colombia would not be able to pay for the amount of debt I have. So I am kind of forced to stay in the US. But yeah, three illed flower. So ailed flower, wildflower, flipped to the side. The nice thing about these Excalibur plugins is they run locally. Yeah. Penguin operator, you saying, well, I see AI as more tech overall rather than some set of products from some corpos. Yeah. The key piece is that tech is always good for production, but the production means are owned by the most successful non-bros that make money. And here I need to introduce the labor theory of the value. The more human labor is put into the product, the more surplus value it has. The successful numbers make money primarily by accumulating those surplus values. Yeah. Oh, interesting. And yeah. It was our little break on AI. Marxist, by the way. Yeah, notice it a little on the right. Anyways, but yeah, we'll it's a little takes on AI. Is the future is a little scary sometimes when you think about AI. Um, but if you think about it a little deeply, there is not much of things to worry about if you prepare correctly, if you're confident with your abilities. Yeah, I use Mox, by the way. It's the new I use Arch, by the way. Anyways, there is no marks in Antarctica, Pingu. All right. All right, let's look it. Let's look it. Well, not looking, right? I can talk to you guys while we do these very sort of low effort edits just to make the code base a little better. Um, yeah. I use Ubuntu, but all right, people. All right. Well, okay. So what do we need to do now? So we have fixed the header stuff and everything. Now we need to take a look at alignment, right? No joke. I use Arch, by the way. I also have Arch on my desktop PC. I I changed to Arch after using Windows my entire life. What, like weeks before coming to SF? So like I have a desktop PC. I couldn't bring it, and like I switched to it, and I only got like what 1 week and a half of using it. Really liked it, and hopefully, I'm hoping I can go back and get it. So so yeah. Um, Meanwhile, I break Arch, by the way. Did this emoji is so funny to me. I put the cursor over and it says kappa. It's like such a like I don't know. It's such a funny emote to me. But anyways, anyways. Um, five months. Yeah. So okay, what do we need to do? We need to fight with the alignment gods. So we want alignment to be 8 bytes, right? But people, we have a little bit of a problem. And that problem is called the header. That problem is called the header because depending on what alignment you want, we are like, how can I explain this? So notice that our block, when it is allocated, it has a single field and it's a uint32. All right. Which means that whatever we provide to the user is not really 8-byte aligned. It's just 4-byte aligned, right? Because this is a uint32 and this is the thing that goes before the user starts writing actual information. So a way we could achieve alignment of the user pointer would be just by, you know, just like adding padding to the struct, but it would be like, it would be kind of foul. Yeah. I don't know if I'm explaining myself correctly. Like, we're just wasting 4 bytes for the sake of alignment when we could be using them for something. What something? Not sure. But it is the advantage of having the struct for the alloc block header. Because we can just create another uint32 and just call it padding. And just call it like 3 lines and then padding. And then everything, since everything is based on the size of this guy, everything just gets automatically 8-byte aligned. And so it like, yes, right? And then we could have like we could have like this. It just feels like I'm wasting space. And I don't like that. Because I mean, inherently, right, you have to sort of sometimes waste space for things to to align correctly. But as we've seen through the development of this memory allocator, sometimes the need for padding can be replaced or used by other components, right? So instead of padding, we just introduce more information that's going to be helpful to us. Um, yeah, and so here I feel like we're just wasting space. Um, so this allocated block header, we need to introduce padding so that it's 8-byte aligned. And let me read the chat because there's a lot of opinions here. That's a fun idea. Valley, welcome back. Use compiler when auto padding. Yeah. Like we can use align as 8 and so on. I was just like, introducing this. I'm saying that we could introduce something helpful that maybe we can use. Wow, the stream is still live. Have you managed to configure Unity? We decided to drop the whole testing. I was so tired of it. I was so completely out of it that we determined the testing stuff is gonna go for tomorrow, and we're gonna do it tomorrow, not today, just because I don't want to look at the test anymore. It's absolutely insane. The compiler will auto padding, yeah. That could be give a false sense of security because he's still doing some of the layout manually. Yeah. What's the problem with just storing what is the alignment? Maybe the padding will get used up later. Don't worry about it now, though. If the users malloc a bunch of small stuff, that's their problem. No, that is true. That is true. So currently, what I'm thinking is like the padding actually can be used for other stuff, right? So now that we have this, right, that struct will still be 4-byte aligned even with the padding. Yeah, but like, well, not really, because we ensure that the heap starts as an 8-byte aligned address, right? And so if the struct is just 8 bytes long, it's just gonna keep it aligned, right? And if you're 8-byte aligned, then you're 4-byte aligned, so everything will be fine, right? Maybe I'm mistaken. But yeah. So my grammar is horrible today. Really, it's because I rewrite slightly, but don't backspace enough. I see, okay. So what I'm thinking is like, this padding could be used in the future, right? Could be used in the future for something else. What's something else? Well, I don't know. But it could be used for something else. So for example, I don't know, a checksum, right? To check that the user hasn't messed up with the header. Right? That is an example of something that could go there. And etc. Right? And because of that, a bunch of people have followed. Wait, that's great. So Wenzeli, thank you very much for following. Robobobodo, X-Knight Told Gamer, Tonchek too, and Gamma Raging Hulk, thank you. Twitch has once again defiled my holy emoticon. What do you mean? Oh yeah, I hate that too. I like to write like the actual emojis with the colon and then the parentheses. I like the one that's like colon and then a huge D because it's like yay, it's like super happy, but then it like changes it. It's like very annoying. Anyways, but yeah, so over here we could make this struct be 8 bytes long. And will this change? So is there behavior in the application that depends on this thing being only 4 bytes? And the question is, not the question, like the answer is, I think so, maybe, question mark. So, currently, everything uses size of the alignment, right? Size of alignment. And sorry, size of not the alignment, size of the allocated block header. But we also see that to go to they did it again. There might be parts of the code that depend on this being full byte aligned rather than ached. So let me check that is the case. Okay. So the thing is, an example, right? A footer is full bytes only, full bytes. And the problem with that is you have 8 bytes at the beginning, so that's the header. Then you make user section be 8 byte aligned too, so now that's 8 byte aligned in total. But then you attach to it the footer, which is 4 byte aligned. Right? Really bad. Really bad. And so now the entire block is going to be 4 byte aligned rather than 8. So that would mean that we also need to introduce padding to the footer, which now makes the use of memory be like even worse. Don't even get me started if the alignment is something even greater, right? Let's see. Also, a heap allocator should default to 16 byte aligned. I imagine this because of the SIMD instructions and stuff, yeah. It's probably fine on ARM, but on x86 some instructions will crash if an address is not 16 byte aligned. As a result of this, malloc does 16 byte alignment, and the system VABI mandates 16 byte stack alignment for function calls. Would it make it easier to put both headers in a union so they are the same size? Well, I mean, they basically it's not that fact, right? It's the fact that both of these headers are A byte aligned. Like this one is 16 bytes long, this one is 8 bytes long. And so what happens is never mind. Okay, we're good. I was wandering off and then realized that we're good. Never mind. Okay, we're good. Great. That's it. Guys, we're done. Okay, let me see. Vicente Alencar says the top comment. Cool allocators would allow you to specify an alignment, but malloc and friends aren't that cool. All right, buddy. Thank you for saying our allocator is not cool. You're getting banned. No. Valid opinion. If a byte aligned, a programmer will not be able to write some SIMD optimizations on allocated data. Yeah. So, like, once again, it is something that we have to take seriously. And I'm assuming we're writing a malloc replacement. Yes. We're writing basically something that would allow us to write malloc. Not to write malloc. No, not something that would allow us to write malloc, but would allow us to do the same things malloc does. As such, one way we can introduce things is, well, I would call aligned alloc, also a friend of malloc. Wait, is that a thing? Aligned alloc? Interesting. Okay, so one thing we do have is the definition of this, little guy called alignment, which allows us to define alignment. So if it changes to 16, then my allocator should be able to align to 16. And so what we do with this thing currently, it could work just this way, right? The thing is, we should condition the size of the header on this alignment guy, right? So we should be able to add like padding depending on what alignment is. The thing is, I don't have experience with macros, so I don't know how to do that. Like, how do I introduce padding that depends on what that value is? Let's try and find a solution. So, how to align a struct according to a define preprocessor instruction. Like, I don't know how to look this up. In C. So do we just do the align as that Vought suggested, like Viet Vanquish suggested, or do we just do something else to determine it at compile time? Okay, I think maybe we can use over here. I mean, sure. I mean, for a search for something like this, which we already would find in Stack Overflow, it makes, yeah. We can just take a look at the AI overview. To non-unpack struct in C using preprocessor or compiler instructions, use pragma-pack to force custom byte alignments or standard keywords like align as for specific boundary alignments. You can change how the compiler pads structure members by wrapping the definition with pragma-pack. This is commonly used to remove padding bytes for binary files or network protocols. Hmm. So we have pack and then pop. Ooh, pack to n byte boundary, pack to set to default. So align as may be what we're looking for. If you're using C11 or newer, the standard way to enforce a specific alignment boundary on a struct or its members is align as specifier. Okay, I see. Compile specific attributes. If you're using GCC or CLang, okay, yeah, I don't think we want the... So we can just use align as, and then that will solve all of our issues. Probably, right? But like align as would... So one question, like would align as make the starting address of the header be 16 byte aligned, or would it make the entire struct be 16 bytes long? Which one of the two? Or both, right? Because the distinction is important here for a memory allocator. Amen. Aligners may not work with dynamic memory management. Wait, what do you mean? Is there a problem with align as? It would change size to multiple of alignment. But it won't care about where the struct is starting or something. Well, I guess like, right, there would be no way to check that, right? Because you can start a struct anywhere in memory, whether or not you're responsible with it is the thing. The thing mostly works on compile time vars. Yeah. Like currently we have the alignment compile time variable, so we're just gonna use that, right? I would see no problem on using that. So we can just do align as. Ooh, it's not appearing, which is a really bad sign. And then we just input alignment. I think this is the way they did it. I think I'm just putting it the wrong way. Oh yeah, it's after struct, so never mind. Oh, sorry. That was a sneeze. Align as. Right? Hello? Align as, and then we align it as an alignment. Hopefully that works. No, it doesn't. Very unfortunate. Align. Align as. Then alignment. Koala? No. Okay. Are you compiling for C11? Great question. I don't know what version I'm using. Where can I take a look at the version of C11 that the extension is using? Maybe that's the edit configurations probably. Mac, CLang. Version of C standard, C17, yeah. So we're using C17. But the thing is still complaining. Expected an identifier. What is the problem here? Is it that I have to, like, I cannot use typedef for this? But it seems like I should be able to, right? If I just do struct, align as, yeah, and then I specify 8, and then I call it koala, and then I do the struct thing. Oh. What? Is VS Code just stripping? Is the IDE complaining or the compiler? No, the IDE. So maybe align as after the this of the structs before the name. Oh, so maybe that would be a little weird, but maybe. And then here we say to test. Because like it should work with a guy like this. And in fact, the whole thing actually like see it like it was previously given me when I do, you know, align as. Oh, it actually doesn't autocomplete. Okay. That is interesting. Why is this happening? Why is the IDE complaining? There must be a reason. I think if we compile this, it's just gonna compile just fine, right? So if I just do like make, no, well, never mind. Something I may make test. Oh, oh, never mind. The compiler is also. Let's see. Expected identifier, or parentheses. Expanded from macro alignment. To match this parentheses, type specifier is missing. Defaults to int. Do not support implicit int. Huh? Only members of a struct can have that, apparently. Oh, really? So why did AI overview tell me this? Oh, do we need to include std align? Oh, wait, that's probably the reason. I'm just stupid. Wait. Hashtag include standard align .h. Is that it? Were we just dumb the whole time? Let's see. Will the compiler complain right now? Oh, it keeps complaining. Yeah, never mind. Well, that was not the solution. Oh, wait. Now it autocompletes too. Align us 8, and then koala, and then finish the struct. And then um32 to hello. Yeah, this doesn't seem to be a thing. Yeah, so word aligned, yeah. Okay, so I imagine you guys wait. So we need to apply it to the field instead, rather than the entire struct. If that's the case, let's try that out. So we can just get rid of padding, right? And then we can do align as, and then we do alignment, right? But it doesn't work. Huge problem. Well, I looked it up, and align as is deprecated in C23. LOL, they replaced it with align as. Not sure what the difference is, or what the problem was for the matter. You typed it wrong. Did I type it wrong? Align as. Wait, which one did I type wrong? Oh no. Wait. Then int and then first. Yeah, this is what we're doing now. The A should be capitalized. Oh, sorry. In the comment, it said with a. Well, it still doesn't work. Right. C cannot instantly introduce new keywords in the namespace reserved for the user. They need to give them some time to update their code. Also, only one underscore. Oh, it's only one underscore? I thought it was two. Okay. Let's see. Align as. So align as. The autocomplete is not picking it up, which may be an indication that we're in trouble. Oh, it works! Yo, perfect. Thank you very much. Wait, so should we try and use it in the struct itself and see if it works? No, it doesn't. Okay, well, looks better here. And then that shouldn't complain, right? Now if we reset, Ouch. Oh yeah, no, this is totally fine. This is totally fine. Well, kind of. Yeah, because oh, we have no make file. Oh, I think we left the make file in the other branch. That's okay. Make file. Let's just write it from scratch. Today we learned how to make a make file. So let's put a knowledge to test. Make. So we're gonna put a flags variable here, and I want to always compile with debugging options. We're going to write an make nalloc, right? That's going to grab everything. So it's gonna grab memlib.c. It's also gonna grab mm.c, and it's also gonna grab the red-black-tree.c, right? And then it's just going to compile it. So it's going to run GCC. It's gonna use all of the prereqs. Then it's gonna output everything to something that has the same name as nalloc.o, and I think we're fine with it, right? And then all includes nalloc. And then for clean, we're just gonna do rmrf and then nalloc.o. Great, awesome. Okay, I think that's all we need. And so now if we compile, make nalloc. Undefined symbols for main architecture. Oh, I mean, of course, yeah, there is no, sorry. Test is the one that should be here, so test. Maybe instead of nalloc, we make test. Then we restart. Then we make sorry, not nalloc. Make test. Okay, make clean. Not only nalloc, but also test.o. And test should have a .c. Yeah, there you go. Okay, let's reset this. Let's make test again. Compiles, let's go. Okay, so that is the correct way to do it. Wonderful. So this guy is gonna be 8, 8 by line, 16 by line. It's just gonna follow alignment, right? I think we solved alignment, right? With this, we fixed alignment. Since what we have right now is, so everything we've been working with, we try to align it to whatever size it needs to be. And the way we do that is by calling this align function, which automatically aligns things to whatever alignment is. So that is an advantage that we did before, sort of looking into the future and saying, ooh, right? Ooh, it's possible. It's possible we need to change the alignment. So I'm glad we did that. Over here, though, we do need to make this free block header now. Actually, no. We only care that the alloc block header is the one that's like, 8 by line or whatever. Awesome. Okay. Let's see. Ooh, there's a lot of things. Also only one underscore. That's why everything new gets uglified. But why duplicate the temporary keyword? That seems a bit strong. Autocomplete is never working on half of the... Yeah, no, that's true. That's true. I don't know either. Make has cursed defaults for C code that you could. Please don't. Default rules specifically. Yeah, no, let's not do that. I find the default makers convenient and not sure about what it would do with dynamic data. So what do you mean with dynamic data? Because currently we know everything at compile time, right? We know everything at compile time. We need to know about the headers, everything aligned to where it's supposed to be. So, yeah. Okay, so I'm still standing better than I ever been. Maybe like a true survivor. I think this is it can just go. Yeah, wait, I think we have it, right? That would be everything we need for alignment. So let's think about it. Let's think about it. So what we have right here, right, when it comes to a block, let's reason thoroughly about the nature of a block. What makes a block a block? So currently what we have here, right, is the sort of layout of a block. When we're creating a block, we perform, okay, there's something that we need to do now that I realize. Wherever we use size of something like block, free block header, there you go, here. So in these instances, we need to align it. Yeah, align. And then do we align again? Okay, yeah, we align. Okay, yeah, it doesn't matter. So what we are doing, oh, sorry. By the way, aligning the field member like that will cause padding before another element if you add one instead of at the end of the struct, which might waste space. Oh, wait, so alignment creates extra space at the beginning of the struct rather than the end? The align as? Yes, I know. Like, I want to specify the alignment of the struct itself, but like we tried and it just didn't work, right? If we try to do align as and then pass in the alignment, like it just tells us, oh yeah, this doesn't exist. Yeah, no, you're wrong. So it's like it's like it's not it's just not there. It's not available, it seems. So now it says expected an identifier and so on, which is the problem, right? So yeah, you can't do it on the type, but on the variable. So liners on the only field should be the same. Yeah. But I was just trying to see what Vieto Vanquish was trying to say. Means that the element will have to be 8 bytes. Yeah, the element being 8 bytes is completely fine. No? Of course, if I add something else after this, then this is going to occupy 8 bytes. So now the entire thing now occupies like, 12 or something like that. And in that case, like we will have to change it. But for now, we're only storing one thing, so it should be fine, right? You can't do it on the type, but on the variable. Using aligners on the only thing, yeah. Where do you create an alloc block header? So that's the thing. We don't really create one. Or like we do, but we just like mem copy our way into it. It's what I mean. Like we don't make up. So we just grab memory in the heap and we convert those bytes to what they should be. I think it's better to just add it here rather than going to every instance where a header is created and making sure that we are able to call the alignment, which would be absolutely impossible to do. We simply just put it here, right? Oh, let's see. It seems like Vanquish sent a god ball to that. Since C always rounds the size up to the alignment anyways, yeah. Wait, I think I'm wrong. It appears to be using the pattern for the next element. LOL. I see. Anyway, I'm going to sleep. Bye-bye. Bye-bye, Best Creeper 21. It was good to see you around. Then you already control the address where you copy to and can align manually. Basically, yeah. So that's exactly what we're doing. So the thing is the following, right? I don't care about the starting address. I care about this thing being however alignment is bytes long. Because the way it's working right now, we have a block, right? We have a block, and this size is represented by the allocated block header, and this thing is represented by the free block header. So there's two notions of a header that we have. Because when we free something, we don't need this information, so we allow the user to write down on this, right, and get rid of it. And so what happens is we're going to need right? If we 16 byte align this guy, that's completely fine, right? Perfect. But you would need it to be the 16 bytes long, so that when the user data arrives, which is all of this, the block knows how long this has to be in order to also be a multiple of 16. And so the addition of these two makes it so that the next block starts naturally at a 16 byte aligned address. So we know that the size thing will always start at an address of alignment. So that is not my problem. My problem is making the size of this thing be the alignment, right? Be as much as the alignment. Not that it starts at a specific address, because that is natural. I just need it to be of that size because that is what allows the naturality. And that's why I'm like, okay, yeah. Does it actually increase the size, or does it just make sure that it starts at a given align address? And I think it does just, it makes the size be the same as this. So yeah. I want to check out the God bolt, so let me take a look at it. Oh wait, sorry, I included a little thing. Compiler Explorer. Okay, let's see. Oh wait, yes. Okay. Oh, okay. You're just grabbing the usual GCC compiler alignment guy. Oh, okay. Yeah, sure. So you're doing alignment and then next align and then this guy int y align 2. Return size of, return size of, return size of, return size of. Okay. I think that if we run this, we're ever able to execute it. Okay, so you're saying that it actually is using the space for the next field? So wait, how do I run this? Do we know how to run this? I'm so sorry, I haven't used like Godbolt that much. I only use it to take a look at the assembly, but never really had the need to run. Oh, okay. Yeah, sure. So it is basically the same, right? Like they are all just exactly the same. Perfect. Okay. It means that we can just do this and be fine. They'll be aped even if you remove int y. Okay. I see. Oh, so it aligns the struct. So it doesn't make it be of a given size. It just makes sure that the starting address is a byte aligned. So it doesn't make it that size. Right? Ooh, that's okay, because that may be problematic. I guess we can just try it out, right? So I'm just gonna do this typos alignment and then align 2, and then we can just create something like, some kind of char star pointer and then make it equal to malloc. And then I maybe don't want godbolt because I want to be able to. Well, actually no, I do. Malloc, which is included into the standard library if I remember correctly. stdlib, and then we malloc however much is needed. Does it allow me to import stuff? Anyways, ooh, you share. Let's see. Have you seen the notice that invented emoticons? It's at the bottom of Scott's phone switch. What is the notice that invented emoticons? So, what does that mean? Life and career, emoticons. Fallon was not the first to suggest the concept of emoticon. Although the idea was never put into practice. I often think there should exist a special typographical sign for a smile, some sort of concave mark, a supine round bracket, with originating the first smiley emoticon, which he thought it would help people on a message board accountability to distinguish serious posts from jokes. He proposed the use of this and this for this purpose, and the symbols caught on. The original message from which these symbols were originated was posted on September. The message was recovered by Jeff Baird on September 10, 2002 and read, from Scott E. Fallon. I propose that the following character sequence for joke markers. Read it sideways. Actually, it is probably more economical to mark things that are not jokes, given current trends. For this, use this. Hey, that's funny. Really good. I have a copy of it saved to my desktop. Size is always a multiple of alignment. Not really. Which is a little bit of a... So size is not necessarily a multiple of alignment. Is a multiple... So it's like... Let me think. Actually, no. It is in this case. In this case, it is. Yeah. So, yes. So what was I mentioning in this? Well, before, right, we needed all of the blocks. We had like all of the blocks be start at an 8-byte aligned address. So what we would do is we would have size be 4 bytes and then align this to be the needed quantity to make something here plus 4 be a multiple of 8. So this could potentially be modulo 8 be equal to 4, right? So like previously that was not the case, but now it is. Yeah, now it is. Anyways, so. Yes, the error is that you're missing the size. Malloc is there. Oh, does the highlight just say, oh, too few arguments? Okay, that's so funny. Okay, anyways, so let's allocate like 24 bytes or something like that. And then we can just try to do PCR. No, he's correct. The compiler must adjust the size to be aligned so that an array of objects is still properly aligned. This way, setting the alignment and forcing the compiler to pass better. No, yeah. Wait. But like, I think we're referring to different things. Like, I meant that size is a multiple of the alignment, as in the value that's being stored in size is a multiple of the alignment. And then I said, not really, because previously we had it be this way. And then I was like, okay, now it actually is. Whatever's stored here is actually a multiple of alignment. In the sense of this whole thing, yes, of course, it's going to be a multiple of the alignment. Yeah, we agree on that. So yeah, here. So to this pointer, what do we want to do? We maybe want to, reinterpret that pointer to be something like aligned to, right? Well, actually, how would we do this? How do we... Oh, I think the best thing would be like, actually, I think this is fine, right? What is the size of aligned 1? It should be 8, right? That's the way we verify. Yeah, it's 8. Yeah, I don't know what I was doing. And aligned 2? Yeah, it's still 8. So then whatever we put after, yeah, that's fine. Okay, that's perfect. That's perfect then. So this like fills the space, right? To be aligned to alignment. Perfect. Then we're done with it. We're done with it because it means that size is now like the space occupied by size is now 16 byte aligned, which means that the pointer that we give to the user is also 16 byte aligned, which means that whatever the user puts in here is also going to be 16 byte aligned, and so on and so on and so on. And then we put this guy over here. Also, a question: Mimalloc returns 16 byte aligned addresses, or does it return 8 byte aligned addresses? Wait, I think this is something we can just look up. Does Mimalloc return 16 byte aligned address? Depends on your system. I mean, I imagine it does, right? If it aims at replacing malloc, then yes. The CSC plus that guarantee that malloc returns a pointer suitably aligned for any standard type. Max line T. A model system is regularly translated. Not universal. Ooh, interesting. No. We typically return an 8-byte line address. Fundamental alignment for double and long integers. Interesting. So for 64 bits, ooh, so is there a single universal thing that we can just use to know what the alignment should be? Do you guys know if there's a way to do that? To be like, oh, what is the alignment that we should use, or like that ideally can be used? So maybe ARM returns 8-byte line, and then this guy returns 16-byte line. Is there a way to tell that? Yes, I can't remember the. Oh, okay. I do prefer my aligners macro to be built-in aligners, though, because you can't do it directly on the struct. Yeah, I know, but then it would be like compiler dependent, no? Which I guess it's fine, right? But like currently we just need it here, so I feel there is not much of a problem with it. I'll find it, but the standard specifies a type that is the largest primitive type that you need to align to. Ooh. Is that what the reviewer was mentioning? It was saying max align T. So let's look at max align T. Is a standard layout, trivial type, trivially called standard layout, trivial type lemma, whose alignment requirement is at least as strict, as large, as that of every scalar type. Pointers returned by allocation functions, such as malloc, are suitably aligned for any object, which means they are aligned at least as strictly as this. So we can just use this to determine our alignment, right? And then we replace alignment for a call to size of max align. Oh, is it a C++ construct? I think it is. Oh no. In C. Mimalloc. Max align T. Yeah, wait, max align T is an actual thing, right? So why is it not appearing here? Oh wait. Never mind. Seems like it exists, but the IDE just doesn't, just forgets about it. Okay. That's great. Okay, we can just use max align T. Identify max align T is undefined. Oh, never mind, it's undefined. Well, GG's. Alignment. Let's just do 16 for now. Max align T is defined as C header files distributed on your system. It's almost always 16. The thing is, like, which header file, right? Which is, I think, a question I should do. In what header file is max align T defined? stdef. Okay. So here, and then maybe we can include stdef.h. And then we can do size of max align T. Yo, perfect. Thank you so much, Valley. Yay. Yo, that's awesome. Okay. So now, we wanted to fix this to be compatible with any alignment, but honestly, I think we can just require the alignment to be a power of 2. Is that too unreasonable? Because this works for powers of 2, right? It doesn't work if I just make the alignment, if I make the alignment 23, like, this thing is not going to work, the align function. Like, is it reasonable to assume that it's just going to be a power of 2? Something like that? Anyways, I think it's safe to assume 64 system these days, unless you really want to go crazy and support all embedded environments. Yeah, I mean, if we can use size of max align T, it's cheap, it's free, it's there. So I think we can just use it, right? rather than just using 16 hard-coded. So yeah, that's all. That's all. Yeah, because this guy seems to only work for powers of 2, right? So if we specify something different, like, alignment is going to be for 24 bytes or 22 and so on, like, it's not going to work, but I think it's okay. It's fair to assume that it's going to be a power of 2. You could do align of Michael 90 to be totally safe, but it should be the same. Okay, it's the same, but I guess we can do align now. Yeah, that's fine. I'm just going to get rid of this to do. Okay, fix the VS. Color should be in the red black tree file. Oh, okay. Yeah, I think this is also fine. So, yeah, it's fine. One thing. So color should be in the red black tree file because, like, semantic separation and whatnot. How the problem is the red black tree file imports from mm.h. So, and mm.h needs this color field. So if I just put it over here in the red black tree header, right, and I just define it here, then like mm.h won't have access to it because it would need to import the red black tree header file, but that red black tree header file already includes and then circular reference. So is there a way to have this here, but allow to use it too? Do we just use a forward declaration of sorts? But like, if that's the case, if we do something like this, enum color, then we're not going to have access to like the members, the members. Put it in a third header, include it where needed. I guess so. But like then it becomes like, we have one single file to just store one struct. I very much just prefer to have it here rather than bothering with it. Because it also has a natural place here. Right? So it's fine. Let's see. Vanquish. So you're saying you what? You could do a line of, yeah, I'm going to head out to dinner now. Good luck. Good luck, Vanquish. Good luck. Good luck with dinner. Hope the dinner is great. And thank you very much for all the people that have been following. Humanizer, Cjix. Cjix? Perfect. And yeah. Okay, I think we have solved the issue of alignment. There's nothing else in this code base that depends on alignment. I am willing to assume, right? Because we have been very careful with that. Okay. Yay. So I think we can just commit this, right? Also, we need to include the .vs code to the git ignore. For some reason, it was not included there, which worries me. Reset. Then what branch are we in? Main. Okay, that's fine. Git commit feet add general alignment. Add customizable alignment, let's say. Feel that's a better name. Then we can push now. Yo, okay, perfect. So guys, what else do we need to do? Are there any to-dos in the code base? To do? Okay, this is an mn copy. We don't really care about it. Change new node name. Oh, that's fine. I think, well, yeah, instead of new node, maybe you want to call it block. It's like block. Perfect. Because it's the block that we are inserting. Perfect. Yay. Okay. So we have the to-do of the copy, which I think we don't need this copy anymore. It's just they're wasting space. Perfect. Now let's go to a to-do.markdown file. So what we see is add logs to events. So we should be able, we should implement a logging system that tells us what's going on. Then we can create a heap checker. There's never 2 plus 3 blocks next to each other. I don't think we need a heap checker for now. I think this logging is actually pretty relevant. So -n, and this is just a matter of style. Style in the red black tree. Rename new node to block. Then we can also push this. Perfect. So let's introduce some logging. I think it's going to be better for tomorrow if we introduce the logging and then we have the tests and stuff. So we can do git checkout -b, and then we can do something like what? Test slash logging. Is that a proper name? I think it is. Let me know if you guys disagree. But we can introduce logging, and the way we're going to do it, great question. I don't know. Guys, does anybody have experience on on where logging should be introduced? I imagine it's like, you know, the main functions, right? Partition block, and then we introduce something like partitioning block, B2, and stuff like that. So yeah, but like, how do we do that? But like, more than how do we do that, it's like, in what places should it apply? And yeah, I guess how do we do that, right? Because I know there's people that usually have something like, you know, if there is some flag defined, then print all of the logs. Otherwise, you know, let them go away. I also don't want the logs to you know, hurt the performance of the functions, because if we have an if over here, then that's another branch that we have to go through. So does anybody have ideas of how we could introduce this logging thing? In the meantime, I think I'm just going to be looking online. So how to log in C. So what is the, oh, no, I mean, if def bar debug, define debug printf else and if. Oh, wait, is that a thing? Okay, so you mean, so I should do it in mm.h, I assume, right? Question mark? I'm gonna delete this custom thing, and then I'm gonna copy all of these functions down to where they are. So these are block member variables, temporary, block names, temporary, and then here, I'm going to say main functions, I guess, and paste them here. Okay. So do you mean doing something like if def debug, then I do hashtag define debug printf and then I define it as printf, otherwise, right? Else we want to define, maybe in the next block, define debug printf to be nothing, and then the end if, something like this. But then how would I use it? Right? Because then if I call parentheses on this, then it like wastes everything and makes it go away. So do I accept like a parameter, like an x, and then an x here, and then I define this to be like printf, and then x, and then I pass that, or what do I do? Or is this just fine? Because what I'm confused by is if we go here and then we say like debug printf, and then we call it with arguments, right? Once we put something here like hello, if debug printf is not available, then what happens to this? Is it just an expression and then, okay, it must be defined printf in the else case, otherwise it will not remove the parentheses. So this, is this what you mean? Interesting. Okay. Yeah, okay, so that is the same, well, similar to what I was thinking. Okay, good. So that is the thing that does it. Okay, perfect. Yo, let's go. So debug print and then hello, and then, oh wait, this is actually pretty nice, because that means we can just print the logs and not worry. Yo, wait, that's excellent. Okay, so we partition block, and then we can say partitioning block at address. I've seen many people include something like this, where it's like logger, and then they do that. Should I do that, or do I just include the message? I guess that we can define that in the macros anyways. Partitioning block at address, and then I would need to append the heap pointer, which should be a number, at address, heap pointer address, this, to a left size of, and then another number, remaining this. Remaining is %d. Right, so that should be it. So a partitioning block, I think we can just specify this to left size of d. So we would have to specify, well, what is the heap pointer for the block? What is the, after here? What is the thing that we were trying to do? So size needed, right? What's going to be the size of the left? And then whatever's remaining, it's going to be the total write space. Right? Total write space minus size of an allocated block header. So something like this. I'm not entirely sure though, because we are positioning the block this to have a left block of size this, and then the remaining space is this much, right? Total write space actually. Of size this much. So something like that, maybe we can do. Oh, sorry, you guys cannot see. I think so. No, I'm just gonna close this panel. I don't know why I have it open. So we have something like this. Yeah. Okay, looks good. That's fine. Great. Okay. And so now we move to here. Yeah, if you don't partition, just don't do it. Coalesce blocks. This one's important, right? This one's important. And I think we do the asserts, then we do the new size, and then we debug print here. Debug printf. Debug printf, and then we're gonna printf what? Well, we're going to say coalescing, and then block 1 with block this. Size of new block is, and then we append the new size. Perfect. So the first one should be block 1, the second one should be block 2, and the third one should be the new size. Okay, great. So now we say inside of malloc, maybe we can debug printf allocating actually allocating that many bytes. So you say size bytes. Yeah, and so here we just say here we're gonna say something like, well, I guess the debugging would be here. So debug and printf. Then we say percent block, not percent, sorry. Percent d block was free. Was what? How do we make a conditional? Can I just do something like this? If it is free, we say percent d block was freed. Otherwise, we say percent d block was allocated. Right? Like was occupied. Has been freed and then has been occupied. There you go. And so now we can travel down and say allocating these many bytes. Then we continue and we say, okay, remove from the regular tree, set it to be free. Then we partition with it. And if there's a leftover block, we're just going to set it to be free, which is going to say like, ooh, brother, you changed it. And then we're going to log like, oh, we're using this specific block to satisfy request. So dv printf, I'm going to do something like, I feel like I want to do malloc, right? Malloc. Then request for percent many d bytes sufficed, or like, yeah, I think sufficed is a bit sufficed with block, and then we append what block was given to them. So that would be request for size many bytes was sufficed with block, and whatever block we gave them, which would be free block. And this is going to be a common pattern, because whenever we remove this, okay, here we have a debug printf, does something like, malloc keep expanded to, and then we specify what it should be. D. We say mem heaps. Well, mem heap size. Well, by actually by. I want to know how much it was expanded by expansion size. And then we include the little guy here. Did you learn how memory allocator works before creating one? Yes, of course. Like a very naive memory allocator and what the purpose of a memory allocator was, and then doing that right now. We're now implementing ours. Welcome back, by the way, Xproof. All right, we're implementing the logging for everything. Nick Volso would be proud right now. So we have debug printf, malloc, and then heap expanded by this much, and then we have an expansion size. And then what we can do is we have that, but also we need to keep track of the times where we return to the user. So we expand this, we do all of this, and then we return here and we say, well, request for d bytes was sufficed with block %d, and then whatever block we're given back, which is the last block. Awesome. Perfect. A good thing to assert is that whatever we're giving to the user is not free. So not block is free. Actually, that is a good thing to do. So let's just go to the to-do and say that one of the things we should do is sort of add a bunch of assertions, right? You just add a bunch of assertions, look for the code and try and see where some assumptions are satisfied and they just assert them rather than just assuming them. I want to do that in one structure step. So then free. Well, with free, how did you learn how memory allocator works? From a book, video, online article? I learned from a video. There are these Carnegie Mellon University lectures on a heap allocator. They dedicate like one class, two classes actually. And so I just looked at those two lectures and I was like, oh, okay, I need all I need to know. I have all I need to know. Yeah. So that's it. Anyways, we have here the free function. Neat. But yeah. So I just, you just look it up like, oh, what is a memory allocator? And then it just explains to you and that's it. Yeah. So we're also going to add a print statement here. So then freeing block and then %d. Then we want to specify who the block is. So we're going to do this. Right. Freeing blocks this, and then we assert that. %d, and then we append the block. Perfect. Then what else do we need to do? Blah, 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 blah. We have this here. I'm going to reinsert it to the red black tree. Yeah, that's fine. Then with realloc, we need to do a similar thing where we do debug print of reallocating this block. We just pass the block to block, right? And then we say looking for size, and then the size that the user provided. Perfect. Then when we actually reallocate it, we want to know where, like, which block satisfied the request. Printf, and we say, well, comment straight from realloc. Reallocated block, and then we say which block it was to, I don't think we need to specify it's a block, from here to here. And so now we say block, which is the original one, to left, well, no, not to leftover block, to, oh, actually, what is the past of shrink? Is it shrinked or shrank? I'm pretty sure it's shrinked, but please correct me. Shrinked this guy to this much. So block, and then we say dk size of the block. Perfect. And then we're gonna go here. Whenever we return, we're going to say debug, well, no, dbg la Fortinetti o la Babadini. Okay, debug printf, I'm gonna say realloc, and we're gonna say reallocated this guy to this guy. So which guy? Block, and we moved it to block. Oh, what? Oh, okay. Realloc. Just expanded block. New size is this much. So what is the new size? Well, whatever the dk size of block is. New size is this much. Okay. And then here we say partition if necessary. Yeah, over here. So now we need to say printf realloc says reallocated this guy to this guy. New size, well, like dash new size. Oh no, new size is 2 dots, and then I do %v. So we have reallocated block to the p block, and the new size is the size of the p block. Great. Finally, we go here and we say debug printf. Then we say, leftover block. What do we say here? I guess a better message would be merged this guy, new size is this. Okay. And reallocated. Perfect. And then here we do, realloc. Is it going to say something like, we reallocated this block to this new block. So we merged these 3 guys and this guy. The new size is whatever I specified. And so we merged the previous block with the current block and the next block. And the new size is whatever the size of the previous block is, because that's what our header is going to be. Perfect. Okay. If nothing worked, we just do the usual. And so here we just serve another print statement that just says, what should be the name? So it's like realloc, then we say reallocated this guy to this guy. And that's all we need to know. So reallocated block to where? Oh, I guess we have to do the math. Okay. To just oh, this one's gonna be a little annoying. So we reallocate it to just of the memkeep plus the minus the pointer, the new pointer that I was given. That gives me space to the user section, and then these guys. Actually, I think it's better if we just do this. Right. So after we've done that, we simply say, okay, go back by however much the allocated header occupies. Alloc. Okay, alloc block header. Right, so we reallocated this block too, and then we need to calculate what the address of the new block is based on the pointer. And then we just print that, right? That should be fine. And yeah, those are seems to be all the prints we need. Yeah, I think that was fairly simple. So git add, git commit, -m test, add logging. We push upstream. to origin through test/button. Perfect. And so now, I think if we run this file, we should be able to see many of. Whoa, there's an error. Expanded from macro alignment. So mm.h has problems everywhere. Why? Do I just need to include parentheses here? Still has problems. Expected identifier or so line 55. What happened with line 55? Line 55. What? Well, that's not even a line of code. What are you talking about? Wait, is this okay? mm.h line 55, 25. Am I just wrong? Wait, no, this is fine. Yeah. Line 42. Maybe another culprit? Ah, no, line 58. Line 42. Brother, what? Those lines do not even have code. Okay, I think I just need to reload the window. Hope for the extension to update. Oof. Oh my god, it's already 5 p.m. Damn. Okay. Let's wait. Let's wait for the extension. Don't worry, she's really so. She goes at her own pace. Don't pressure her. She has to do what she does. It's an independent extension. Okay, perfect. Yay. So now what we can do is in our makefile, we can run mmtest. Yeah, that's perfect. So mmtest should be able to not complain about anything. Perfect. Great. Thunder 1804, thank you for following. Same for Avisoft, the Artisan XP. Thank you very much for following, guys. Yay! So now what we're going to do is we're going to make mmtest. And it's relevant that we include that into the binaries folder rather than, there you go, bins/that. Make mmtest. Then we're going to do ./bins/mmtest. Oh, shoot. What? Oh no, guys, what happened? Oh, what the hell? Oh, it's putting a dodo in there. Okay, I was so scared that it was hell all over again. Oh, what happened? Guy, why is it stuck? Wait, we don't have any loops, do we? Is it stuck? What? What happened? What did we do wrong? No. Okay, time to pull out the debugger. Oh, we don't include. Okay, yeah, never mind. Need to do this. Flags. Include them too. Reset, and then I need to make the makefile again. Perfect. And then after that, we just say run again. Run again. But yeah. Okay, let's go. Seems like it works. No freezing, no. Oh, it freezes here. Oh, what? It seems like we introduced some sort of change that just made the red black tree start to fail. So if we run the red black tree tests, we should be able to see a problem, maybe? I'm not sure. memory.c, mm.c, arbitrary.c, but then we instead compile arbitrary tests.c. And we run the exact same thing. Make arbitrary tests. Ooh. Wait, what? There is no such thing as... What? Why is it giving me like old errors? 938? Oh, arbitrary test. Okay. Yeah, sure. That one's fine. Oh no, we have to fix the alignment and all of that stuff. No, no. Yeah, I think it's fine if I'm being honest, you know. Free log header. Um, yeah. I don't know. I think okay, we introduced the logging. I know it doesn't work, but we've been here for like what? I've been streaming since 7:15 in the morning. So we've been here for almost 10 hours now. It's been 10 hours. So I think this is a natural stopping point. I think we can retake it tomorrow because we're starting to enter the testing territory, and I want to take that care of that tomorrow exclusively because of what we said last time. So yeah, I think this is a natural stopping point. Thank you very much, guys, for hanging around. Yeah, yeah. Keep thinking about, you know, the current problems, the current situations we're facing, and you know, just remember, life is beautiful. Like, I suppose, but yeah, that's mainly it. I think it's a natural stopping point. I'm also a little tired. Um, I'm gonna make this a little bit less opaque so that you guys can see each other. There you go. That's better. And yeah, it's it was a little bit of like mentally draining because of all of the failures we were experimenting. We pushed through though. Thankfully it went well. I think we have a very nice, you know, progress, fortunately. And yeah, going to be able to work on it tomorrow, hopefully. And so yeah. All right, everyone. Those on Twitch, thank you for following. And oof, I don't know. Really, really tired. I need to eat. I need to eat too. I need to relax. Look at something that is not the code. And we'll have fresh mind tomorrow. All right. Bye bye everyone. Good luck with your weekend. Have a good day. And yeah, I'll see you tomorrow. Tomorrow at 7:15 as usual. Bye bye.